Hello students, welcome back to the course Fundamental of GIS and Remote Sensing Applications. In the previous lecture, we discussed the basic concept of Geographic Information Systems or GIS, understood its importance in real-world applications. We learned that GIS is not just about maps but a powerful system that connects data with locations to support analysis and decision makings. In today's lecture, we will take the next step and explore the components of GIS. Understanding these components is very important because they form the foundation of any GIS system. Without these components, GIS cannot function effectively. A GIS is not a single tool or software, it is a system made up of multiple elements working together. These elements are known as the components of GIS. Mainly, there are five main components: hardware, software, data, people and methods. Each of these components has a specific role, but they are all interconnected. The success of a GIS system depends on how well these components interact with each other. Think of GIS as a complete ecosystem. Just like a system cannot function without proper coordination between its parts, GIS also requires all its components to work together efficiently. In this lecture, we will discuss each component in detail and understand its role in GIS operation. First of all, we have hardware. Let's begin with the first component, which is hardware. Hardware refers to the physical devices and equipment used in a GIS system. It forms the infrastructure that supports GIS operations. Hardware includes computers, laptops, servers, GPS devices, mobile devices and storage systems. Among these, computers and servers plays a central role because they perform data processing and analysis. GIS often deals with large volume of spatial data, especially satellite imagery and high resolution maps. Therefore, high performance systems with sufficient memory and processing power are required. For example, when analyzing satellite images or large geographic datasets, a normal computer may not be able to handle the processing efficiently. In such cases, advanced systems with powerful processors and high storage capacities are used. Another important hardware component is the Global Positioning System, mainly known as GPS. GPS devices are used to collect accurate location data from the field. Engineers and surveyors use GPS to record the coordinates of roads, buildings, and other features. In addition to traditional hardware, modern GIS systems also use mobile devices such as smartphones and tablets. These devices allow users to collect and update data directly from the field. With mobile GIS applications, data can be uploaded in real time, making the process faster and more efficient. Cloud computing has also become an important part of GIS hardware infrastructure. Instead of storing data on local computers, many organizations now use cloud-based systems to store and process spatial data. This allows multiple users to access the data from different locations. In summary, hardware provides the physical foundation required for GIS operations. Without proper hardware, it is not possible to store, process or analyze geographic data efficiently. The second component of GIS is software. While hardware provides the physical infrastructure, software provides the tool that allows users to interact with the system and perform GIS operations. GIS software is used for data input, storage, analysis, and visualizations. It allows users to create maps, analyze spatial relationships, and generates outputs in the form of reports or visual models. Some commonly GIS software include ArcGIS, QGIS, IRDIS, Imagine, and Google Earth. Each of these software platforms has different features and capabilities. For example, ArcGIS is widely used for advanced spatial analysis, while QGIS is an open source software that is popular among students and researchers. GIS software provides various analytical tools. These includes overlay analysis, buffering, network analysis and spatial modeling. These tools help users understand patterns and relationships in spatial data. One of the most important functions of GIS software is visualization. Data that is difficult to interpret in tables can be easily understood when displayed on maps. For example, population density or pollution levels can be shown using color-coded maps, making it easier to identify trends. Modern GIS softwares also supports integration with each other technologies such as remote sensing and database management systems. This allows users to handle large datasets and perform complex analysis. In simple terms, software acts as brain of GIS, controlling how data is processed and analyzed. Without software, hardware alone cannot perform any meaningful operations. Now we come to the most important component of GIS, which is data. Data is the foundation of any GIS system. Without data, there is nothing to analyze or visualize. GIS data is divided into two main types, spatial data and attribute data. Spatial data represent the location of geographic features, usually in the form of coordinates. For example, includes roads, rivers, buildings, and land boundaries. Attribute data provides additional information about these features. For example, for a road, attribute data may be include its name, its width, traffic volume, and together spatial and attribute data provide a complete description of the geographic feature. Data can be collected from various sources such as field surveys, GPS devices, satellite imagery, aerial photography, and government databases. The choice of data source depends on the purpose of the analysis. The accuracy of GIS results depends heavily on the quality of data. If the data is inaccurate or outdated, the analysis will also be incorrect. Therefore, data validation and quality control are important. In recent years, the availability of spatial data has increased significantly due to advancements in satellite technology. Open source datasets are also available, making GIS more accessible. In summary, data is the most critical component because it provides the information needed for analysis. Without data, even the most advanced GIS system cannot function. The fourth component of GIS is people. People are the users who interact with the GIS system. They play a crucial role in collecting data, performing analysis, and making decisions. GIS is used by engineers, planners, scientists, researchers, and government officials. Each user has a specific role depending on their field of work. For example, engineers use GIS for infrastructure planning, while environmental scientists use it for monitoring pollution and natural resources. Urban planners use GIS to design cities and manage land use. Even though GIS involves advanced technologies, human involvement is essential. The accuracy of analysis depends on the skills and knowledge of the users. A well-trained GIS professional can interpret data correctly and make meaningful decisions. People are responsible for collecting and verifying data, operating GIS software, analyzing results, making decisions based on output. Without skilled users, GIS cannot be effectively utilized. Therefore, people are considered the decision makers in the GIS system. The final component of GIS is methods. Methods refer to the procedures and techniques used in GIS operations. These includes data collection methods, analysis techniques, and mapping procedures. Methods ensure that GIS operations are carried out in a systematic and consistent manner. For example, standardized methods are used to collect data to ensure accuracy and reliability. Similarly, analysis methods are used to ensure that the results are consistent and reproducible. Methods are also include guidelines and best practices for using GIS tools. These guidelines help maintain quality and consistency in GIS projects. In simple terms, methods provide a structured approach to the problem solving in GIS. They ensure that the system works efficiently and produces reliable results. Next is integration of components. Now that we have discussed all 5 components, let's understand how they work together. Hardware provides the infrastructure. Software provides analytical tools. Data provides information. People perform analysis and make decisions. Methods guide the process. All these components are interconnected. If one component is weak or missing, the entire system is affected. Here we have real life example. To understand how all the component of GIS works together in a real world situation, let's take a detailed example of urban city planning, which is one of the most important application of GIS. Imagine that a government authority is planning to develop a new residential area in the city. This is not a simple decision because it involves multiple factors such as land availability, population distribution, and road connectivity, environmental conditions, and access to basic services like water and electricity. Let us now see how each component of GIS contribute to this process. First, hardware is used to store and process large amount of geographic data. High performance computers and servers are required to handle data sets such as satellite images, land use maps, and infrastructure layout. GPS devices may also be used to collect field data regarding land boundaries and existing structures. Second, software such as GIS platform is used to analyze and visualize this data. Planners use GIS software to create maps showing different aspects of the city such as road networks, population density, drainage system, and land use patterns. These maps help in understanding the existing condition of the area. Third, data plays the most crucial role. Different types of data are collected, including spatial data like maps of roads, rivers, and buildings, and attribute data such as population statistics, land ownership details, and environmental conditions. Accurate and updated data is essential for reliable decisions. Fourth, people such as urban planners, engineers, and government officials use their knowledge and expertise to analyze the data. They interpret the maps and identify suitable locations for development. Their decisions are based on both technical analysis and practical considerations. Finally, methods are applied to ensure that the entire process is systematic and consistent. For example, standard procedures are followed for data collection, analysis, and decision making. Methods also include planning guidelines and policies that must be followed during development. Now, by integrating all these components, GIS helps planners answer important questions such as which area is most suitable for residential development? Is the location easily accessible by roads? Are there any environmental risks such as flooding? Does the area have sufficient infrastructure support? Based on this analysis, planners can make informed decisions and decision a well organized residential area. This example clearly shows that GIS is not just about creating maps but about using technology, data, and human expertise together to solve the complex real world problems. It highlights how GIS supports efficient planning, reduces risk, and improves the overall quality of decision making. In conclusion, geographic information system or GIS is not a single tool or technology but a comprehensive system built upon 5 essential components: hardware, software, data, people, and methods. Each of these components has its own distinct function, yet they are deeply interconnected and depend on one another. To ensure the effective functioning of a GIS system, Hardware provides the necessary physical infrastructure. Software offers analytical and visualization capabilities. Data serves as the foundation for all analysis. People bring expertise and decision making ability, and methods ensure that the processes are carried out in a structured and reliable manner. When these components work together seamlessly, GIS becomes a powerful platform for analyzing spatial information, identifying patterns, and supporting informed decision making in real world scenarios. Understanding these components is extremely important because it changes our perspective of GIS. Instead of seeing it as just a mapping tool, we begin to recognize it as an integrated system that combines technology, data, and human intelligence. This understanding is crucial for anyone who wants to apply GIS effectively in fields such as civil engineering, urban planning, environmental management, and disaster management. As we move forward in this course, this foundational knowledge will help you better understand more advanced topics. In the next lecture, we will explore spatial data and data models, where you will learn how geographic information is structured, stored, and represented within a GIS environment. Thank you for your attention, and I look forward to continuing this learning journey with you in the next session. Thank you.